make a bit of introduction for our viewers. So here is Miriam from different countries, from Belgium, Italy, and Germany. I've met Miriam in Germany, actually, in Karlsruhe, and she's one of this woman engineers, super smart and super awesome and interesting. And today we are going to speak about how to reduce pollution from in the transportation sector, or specifically reduce greenhouse emissions in the transportation sector. And yeah, now Miriam, I would maybe, if you want to make a short introduction about yourself, you're very welcome. So yeah.
Thank you very much for this nice introduction and for the invitation for this talk. So yeah, as you said, I'm an engineer and study chemistry and sustainable materials in my master's, and now I'm working on hydrogen fuel cells, the catalyst development there, and this in the main topic of sustainable transportation for cars, but also heavy duty and maybe also at this one point aircrafts.
It's perfect. I think your specialization is very useful today and will be even more useful in the future. But maybe let's start from the very beginning for those who don't know, if these people exist, who don't know what are greenhouse emissions and like CO2 in particular. Can you make a bit of brief introduction on that?
Of course. Yeah, all the cars we are using at the moment, or most of them, are based on combustion engines. So we use gasoline, which is fossil fuel, to power our cars, and we emit CO2 by that. So by burning gasoline, we produce carbon dioxide, one of the most known greenhouse gas. And if we want to get rid of this fossil fuel-based system, we have to think about alternatives. And one of them is electric cars, for example, with batteries. So there are already quite many electric cars in Europe. And another technology is hydrogen, which has different advantages, different challenges. And hydrogen works, or a hydrogen fuel cell works like this. We have hydrogen on the one side, so it's also electric chemical cell, similar to a battery. We use hydrogen and oxygen from air, and those together react. And by that, we produce electricity, which then can power a car. And in the end, we have water and no CO2. Actually, the conversion from hydrogen to water, and by which electricity is produced. So it's not really synthetic gas because we don't have any carbons in there. We just use hydrogen, which is ideally produced in electrolysis by splitting up water. So there's really no carbon involved in there. The field that I'm working at the moment is really only hydrogen based. And we start with water, we split it up into hydrogen and oxygen, and this hydrogen can also be stored and can also be used in the chemical industry to then make other compounds, and together with CO2 make synthetic fuels, and then use those in fields where fuel cells are not yet there. For example, in the sector of aircrafts or ships, it's just not feasible yet. And to decarbonize that, or at least make it CO2 neutral, we could use these synthetic gases there in the combustion engine, but it's CO2 neutral because we can use the CO2 from air by capturing CO2. But that's again another
topic. Yeah. But at the first place, I'm not sure if I'm understanding this correctly. So to split hydrogen and oxygen, we need certain amount of electricity, right?
Yes. Yeah.
And because I remember I was learning about that we can use excess electricity, which we don't use from the grid right now, to run this whole process, right?
Exactly.
And
yeah.
this works like an accumulation itself, this system.
Yeah, we can see it a bit as a really large battery. So when we have a lot of wind, a lot of sun, we can store this excess electricity in form of chemical energy, and this chemical energy is hydrogen. So we put the excess electricity in the system where we split up this water into hydrogen and oxygen, and the hydrogen we store for some time until we put it in our cars, for example, or use it in the chemical industry. And then we reverse the process. So it's a larger scale of storage electricity or energy.
But maybe for people who might be watching us and they don't have engineering background, so the first step is to split hydrogen and oxygen, accumulate electricity, and store hydrogen. And then, but can you explain a bit more how can we actually run our cars on water or only on hydrogen without any pollution, and how is that possible? What type of engine is there? And
yeah, of course. In a car based on a hydrogen fuel cell or powered by it, we have on the one side the cell stack, which is similar to a battery. We have many electrodes and a separator in between, and there the electrochemical reaction takes place. So the hydrogen which we fuel in our car reacts with the oxygen and produces electricity, and this electricity is then used in the engine. So it's the same engine as in an electric car, and it has a much higher efficiency than a combustion engine. So a combustion engine is about 30%, since we produce quite a lot of heat. And hydrogen fuel cells, we are at 65%, about, more or less. And by this we have a higher efficiency, and also this makes it also more sustainable, because efficiency is also a big problem in many processes.
Sure. And but why do you think it's if this process more efficient, and if it's not that it's not a rocket science, it's very not simple engineering, but I think feasible engineering. But why do you think it's still not that popular?
Yeah. So exactly, there's many companies are going towards electrical cars, and battery technology is really driven at the moment. But hydrogen fuel cells still have their challenges. First of all, the infrastructure. So it's very easy to just put your car into the socket and charge your battery, but it's not as easy to set a whole system, a whole network of hydrogen fueling stations. In Germany, we have about, I think, 80 to 90 at the moment, and that's also infrastructure, and that means we need to invest in that.
I'm sorry, just one question. 80 to 90 hydrogen fueling stations, not electrical cars.
No, for hydrogen, exactly. I think that was maybe 1 or 2 years ago. Maybe that's now more, but that just gives you a feeling that there is still a lot of investment that has to be done in this infrastructure, and this. Sure. Going to happen. Germany also set now a hydrogen strategy and a roadmap, so there is going to be a lot of investment there, but that just shows that electricity is just so much easier, electric cars, than hydrogen. And also within the hydrogen fuel cells, there are quite many challenges still, which batteries probably had also in the beginning, but there was quite a lot of research going on in that field, and now in the last 5 years the research interest is growing much more in hydrogen, and maybe those steps in technology and development are going to come, or I'm sure they're going to come, but it just needs more research in that field. Yeah.
And can you maybe, we will come back to the barriers. So we are still at the barrier number one, the infrastructure. And if I just may ask a question about that as well. So do you know how a hydrogen station works, and why is it so difficult to and it takes time and investments to build them? Because I don't know that.
Yeah. So hydrogen has to be stored at very high pressures. So hydrogen intrinsically is the smallest element, so it likes to go everywhere through, and it diffuses just easily through a lot of materials, and it has to be stored, I think, at 900 bars, and then later in the car it's at 700 bars, something like that. And that just shows that it's quite difficult in the sense that it's not as easy as electricity, and that gives a cost, of course. And yeah, so it's the pressure which really makes it a bit more difficult, and also the origin where the hydrogen is coming. So hydrogen fuel cells are only as green or as sustainable when hydrogen is really coming from electrolysis. And also electrolysis, the process of splitting up water, is at the moment still costly because we need very noble elements. And yeah, at the moment, a lot of hydrogen is still coming from gas, actually, from fossil-based sources.
That's funny for people who don't know. Like, for example, they buy a hydrogen-based car and they're like, "Oh, I'm clean. I'm, using clean energy." But then, in the end, maybe it's not produced from the water, but it's produced from the gas. That's crazy.
Yeah.
So, and if you produce hydrogen from the gas, natural gas, is it like the process is more like easier, or why is it this?
It's a byproduct, actually. I think it's a byproduct from many processes in industry, in chemical industry. Yeah.
So you mentioned the barrier number one is the infrastructure. Barrier number two is the process of electrolysis requires energy as well, and it's costly, right? And what do you think the other barriers?
Also the catalysts used in the fuel cell itself. So it's platinum. So it's one of the most expensive metals, most noble. And there's really a lot of research going on, also by General Motors, by Toyota, to reduce the amount of platinum and increase the stability in the fuel cell.
Mm-hmm.
Yeah, stability as well, probably long-term stability. Yeah, it's similar to the batteries. They're also the question is how long do the batteries last and give the same performance as in the beginning? How many cycles do they reach?
Mm-hmm. And is it well-researched topic? What are the lifetime of one?
There's a lot of research going on, and also a lot of at least in academics, there's quite a lot of going on for finding ways to make the catalyst more stable. And yeah, also actually the industries are also looking how to stabilize the catalyst more, that it's really, long-term technology. And also, that increases again the sustainability, right? If we are able to make a device or a car which lasts for a long time, that's more sustainable than one which after 5 years is not performing well anymore.
Sure. And coming to other barriers that might exist, do you think that oil lobbies or like natural gas lobbies, big companies have something to do with that? Like if they're involved in maybe stopping the spread of or development of hydrogen technologies? Have you heard about that?
That's a good question. Maybe I do believe that people generally were like maybe 10 years ago, like, oh, you're doing something with hydrogen. Well, that's a bit like far away from reality. And this really changed in the last 5 years a lot, or maybe even just the last 3 years. And I don't know if there's a change somehow in lobbies, and how far they really influence that. I find it difficult to answer this question, but yeah, maybe there was some influence. Yes,
I have an impression that they should tend to stop it because it's a potential threat to their businesses, but we don't know any, or we don't have any proofs. So maybe now we can talk a bit about CO2 capturing, because you've mentioned that you worked with directly with some sorbent materials as well in climb works, I guess.
Yeah, exactly.
So maybe a bit about that, and also we can start from the very beginning. What is CO2 capturing and how is it done and why is it important?
Yeah. Yeah, thank you very much for introducing that. So yeah, as you said, I did an internship at Climeworks. It's a company which 11 years ago was founded by 2 students from Zurich, and they, in their PhD, developed a process where they have a sorbent material. So that's something which likes to bind CO2 at room temperature, so about at 20 degrees. And when you heat it up to 100 degrees, this material releases the CO2 again. So it's not a strong chemical or chemisorption or physisorption bound, but it's relatively weak. So at 100 degrees, we can reverse this process. And by this, we are able to take out CO2 out of air and close the system. And you can imagine it as a filter, or like a, how do you call it in English? Yeah, it doesn't matter. Like a filter box where the material takes up the CO2 out of air. And then you close this box and heat it up to 100 degrees and you just get CO2. And this CO2, you can use it for many things. First of all, you can use it, for example, to make your plants grow better, to put gas into your soda. But most importantly, at least for me, is to be able to put it somewhere where it's safe and where it's out of the atmosphere. And Climeworks also has a project in Iceland where they pump the CO2 down into the earth, and the salts there, the calcium oxides, are transformed into calcium carbonate. So the CO2 is really physically put into the ground. And if you think this big, we would be able to reduce the CO2 from 420 ppm to an amount which enables us to stay below 1.5 degrees, which was set in the Paris Agreement. Because even in the scenario, or imagine that tomorrow we would stop all CO2 emissions, we wouldn't be able to stay below 1.5 degrees. So we need these negative emissions. They're called negative emissions because we create a negative CO2 mass balance.
Yeah. When you were describing the filter, it consists of several sorbent materials, right? And what are those typically?
So there are many different sorts or types of sorbent materials. For example, there's some active coal, so something which is very porous. Generally, it should have a large surface area so that a lot of the groups which like to bind with the carbon dioxide can attach to the carbon dioxide. Usually it's something with a nitrogen bond. So yeah, and others are also some cellulose based, or There's also moths. So
Mox, yeah, I remember that as well. But what about the efficiency of the whole process? Do you think in the long term it's the solution of the problem?
I personally think it's going to be part of a solution, definitely, because as I said, we will need these negative emissions. Already the IPCC, the International Panel for Climate Change, 2 years ago in one of their reports said that we will need negative emission technologies to be able to get below or stay below 1.5 degrees degree rise or temperature rise. And I think also that since this technology is relatively young compared to hydrogen fuel cells and batteries, there's so much space, so much room to improve the efficiency and to reduce the costs. So that at the moment is the main disadvantage, the cost of this process and the low cost of CO2 in the industry market. I don't know exactly what the prices are for CO2, but yeah, burning some natural fossil fuels, getting out CO2 from that and selling that to industry is much cheaper than CO2 captured by this sorbent material in the in this large thing, heating it up, cooling it down again. And yeah, so also carbon tax will play an important role by that, because that will drive the technology even further. And so there's Climeworks, but there are also 2 or 3 other companies in the US and in Canada which are also working on that. And there's a lot of going on. So and they're growing, all of them. So
everything like this sounds very promising. And when I see that number of startups from different sectors which are aiming to help the planet, it's very nice to see all of this small companies, and they're growing and I think the world goes to a good direction. I just hope everything plays well. So I guess now we can just close the topics of different technologies related to reducing greenhouse gases, gas emissions in the transportation sector. And I just wanted to conclude this all. I was surprised seeing that 60% of greenhouse gas emissions which are generated from all the sectors around the world. 60% of them come from personal car usage, so not from the ships or I found this graph. I was super surprised. I was like, because I think technically or like from the engineering point of view, trucks and ships, they emit more because they transfer heavier goods. I don't know. Still don't believe this graph. So what do you think about it? The biggest part of the graph, when it's 888 megatons, I guess, it's from transport sector, and it says excluding aviation and shipping. So do you think we can believe, because I took this graph from the European website, European Commission website, I guess.
Yeah, I find it still quite a lot.
Quite a lot, right? I also think so. We say that there is not aviation and shipping in this graph, then excluding that it might be true. Right?
Because we don't see it in total, because it's just taken out of the system. Yeah, so it's not even calculated in any other sector. So it's really not in the chart, let's say.
Yeah. Now it makes sense.
Yeah, system boundary. That's
even if we are excluding aviation and shipping, it's still a lot of a lot of emissions from only car, like personal usage.
Yeah, and it's crazy how much is done. For example, in buildings, there's so much going on there, or in the last 20 years, there's been so much to improve insulation, to change the heating system, to have solar energy, and so on. And the amount of CO2 emitted by buildings is really reduced. And also in other sectors, in agriculture, in the industry, especially in the energy industry, there's so much renewable energies. But in transport, in the last 10 years, there's quite a nice gap. There is not so much done.
Yes, you're right.
So that also shows that there's just still a lot of potential.
A huge potential, yes. One of the solutions can be to teach people to use their car less and to walk everywhere.
Yeah, and I also would like to add to that even if you're looking as engineers to all the solutions we have, one big part will be also society and also a change in the mentality of what a car is. So especially looking in Germany, it's just still for many people so much as status and identity. And this is changing, and this is also gonna change in a way that we will not belong cars anymore so much and share cars and use cars efficiently. It doesn't make sense that a car is standing 90% of the time outside. And
it's like we use a fridge which we use only 10 days in a year, and we have it plugged in, right?
Yeah, it's nice to compare it with like these projects or buildings or exactly. And then, we're engineers, we're trying to get the efficiency maybe from 50 to 55%, and then you just don't use the device a lot. So, yeah.
True. So, Miriam, thank you a lot for the talk today. I think it was very interesting, and also for our viewers. So, I'm really happy to have you as a guest today.
Thank you, Valeria. Thank you very much for the invitation. It was really nice to talk with you.